0.1% quantity. However, the enol form of acetyl acetone exists in approximately 15% quantity. So, reason. Enol form of acetyl acetone is stabilized by intramolecular hydrogen bonding, which is not possible in enol form of acetone. And from this, so now the question number 4, assertion. Enol form of acetone exists in 0.1% quantity. However, the enol form of acetyl acetone exists in approximately 15% quantity, which is higher. Reason. Enol form of acetyl acetone is stabilized by intramolecular hydrogen bonding, which is not possible in enol form of acetone. So from this question, we have to choose the correct statement. Both assertion and reason are true, and reason is the correct explanation of A. Assertion is true, but reason is false. Assertion is false, but reason is true. Both assertion and reason are true, but reason is not correct explanation of E. If you want to get correct answer, so we have to look, we have to discuss. So hydrogen bonding. So hydrogen bonding can be classified into two types: hydrogen bonding. So hydrogen bonding can be classified into two types. One is intermolecular hydrogen bonding. The second one is intramolecular hydrogen bonding. Intramolecular hydrogen bonding, we say. So intramolecule means hydrogen bond between most electronegative and hydrogen. So within the molecule, we say. So this is within the molecule, hydrogen bond is present, and between the molecule, between the molecules, so hydrogen bonding is present, we say. So generally, hydrogen bonding takes place between hydrogen versus between most electronegative atom. Most electronegative atom in this molecule. Look for the most electronegative atom is, so hydrogen versus with oxygen is a possible. Now let us look for these structures: acetone and acetyl acetone. So and now acetone. So due to the tautomerism process, acetone undergoes enol form. Enol form of this acetone will be like this. Here you can write. The proton shift due to the resonance, this pi electrons move on to this oxygen, then proton will be shifted to this oxygen, then the sigma bond will move between this carbon. As a result of this, we can get a CH2 double bond COH and CH3. So there is OH, enol form. This is called enol form of acetone. So this enol form of acetone will make hydrogen bonding with another molecule, that is called intermolecular, not intra. Now if you take other molecule is acetyl acetone. Now look at this structure. The enol form of acetyl acetone, enol form of acetyl acetone. So due to tautomerism. So just let me take in case, for example, I'm taking this So pi electrons moving on to this oxygen. The hydrogen present in this will move. Then we can write the structure is C double bond O, CH double bond COH, right? Then CH3. So this is enol form of this acetyl acetone. Between this oxygen and this hydrogen, there is intramolecular hydrogen bond. Here is the hydrogen bond. Look for this. The hydrogen bond is formed here. Here is the hydrogen bond. We can notice. So between this most electronegative and hydrogen, there is hydrogen bonding is formed here. And so because of this intramolecular hydrogen molecule, this molecule is stabilized easily. So with this, now we can go for, so which option is right? A option is right. Both assertion, reason are true, but reason is the correct explanation. You can go for this answer. Right. So now let us move to the fifth question. The fifth question. So the fifth question is the match the following. The fifth question is the match the following. What is given here? Haber process, Oswald process, contact process. So let me discuss Haber process. So in Haber process, this is the question taken from the P block elements. So Haber process, by Haber process, what is prepared? Ammonia is manufactured, and Ostwald process. So by this we can prepare nitric acid. Already you know. So next and contact process. The sulfuric acid is manufactured from the sulfur varieties. Contact process we say. And next one is Hall's-Héroult process. Hall's-Héroult process. So aluminium extracted from the bauxite by electrolytic reduction. So Haber process is prepared N2 plus H2, and so oxidation of nitric acid, nitric oxides, we can get nitric followed by the hydrolysis, and we can get contact process SO2 oxidation and followed by the hydrolysis aluminum. So now pick that correct option, choose the correct answer from the options given below. So Haber process will go for this ammonia. Oswald process taken, so third one, and contact process is the sulfuric acid. Third one 4. So third one 4, and Hall's-Héroult process is second option. Second option will go. So D option is the correct one. D option. So D is the correct solution for this. Fifth question. Now let us look for this sixth question now. The sixth question given below are two statements. One is labeled as assertion and other is labeled as reason. Assertion. So what assertion is given here? Now the ion is pK3 berkelium ion less than the Np plus 3. So these are the size of berkelium ion is less than the neptunium ion is the assertion. Reason is The above is consequences of the lanthanide contraction. So see, the question from lanthanide contraction in any form is the most important. Definitely you'll get the question from lanthanoid contraction. See, this is the very from the D and F block element. This question is taken from D and F block elements. So this is a very important chapter, has more weightage. So small chapter but having more weightage. What are the ions are given? So Bk plus 3 and another ion is Np plus 3 ion. So these belong to actinoid family. That means actinoid contraction is possible. So as you know that berkelium atomic number, how much? It is 97. Whereas neptunium is how much after uranium? 93 it is. 97, 93. Okay, so that means so berkelium comes after neptunium. That means so Np plus 3 ion after, so Bk plus 3 ion 97 comes 93. That means increasing of atomic number. As you know that, so from the left to right, from left to right in the periodic table, atomic size decreases, ionic size also decreases. So due to which reason? What is the reason we can write due to effective nuclear increasing of charge, effective nuclear charge we can write. Effective of nuclear charge increases across the period from left to right. So with this idea, due to the effective nuclear charge or due to poor shielding effect of Fr orbital. So what happened means, so the ionic size decreases. So and that means Bk, berkelium ion is smaller. So then that means we can go for this. Both assertion and reason are true. Here is what is the option is given? Assertion, reason are true, but the reason is not correct explanation. Reason is not correct explanation, and one more option A and true, but so this is eliminate this one. Both assertion, reason are true, but reason is R is not correct explanation of A, and so A false, so you can eliminate D, B, D you can eliminate. Now we have to look for this both A and R are true, R is not correct explanation. But here is we can write A because A is the correct option, not correct explanation because this is not lanthanide contraction, this is actinoid contraction. Actinoid contraction we say, due to increasing of effective nuclear charge. Right, I hope you understood this one, and so A is correct option because actinoid contraction, not lanthanide contraction we say. Now let us move for the seventh question. So now the question number question number 7, let us see this question number 7. Given below are two statements. Statement 1, the electrode potential value or reduction potential value of C plus 4 and cerium plus 3 value is how much? Plus 1.74 volts. Statement 2, cerium is more stable in plus 4 state then cerium plus 3 state. So here is we should go for the appropriate answer. We should go. Statement 1 is incorrect, and but statement 2 is correct. So reduction potential is right. That's why. So we should eliminate first option. Statement 1 is correct, but statement 2 is so two statements also right. That's why eliminate B. Statement 1 and statement 2 are correct. Both statements 1. So C option we can go. Now let us see generally what happened. Cerium plus 4 and cerium plus 3. So here is plus 1.74 value indicate, reduction potential value indicate. So that means cerium plus 4 ion is best oxidant. Oxidant means easily it can get cerium plus 4 changes into cerium plus 3 easily. So means get reduction, means oxidizing agent, means so gain the electrons. So that means the cerium plus 4 easily oxidize the water, oxidize the water for electrons purpose. So cerium ions react with the water, and so because of its oxidant property, so that means cerium plus 3 ion is stable. Cerium plus 3 ion is stable because this is a group oxidation state. Group oxidation state. This is oxidation state. This is group oxidation state of lanthanides. Group oxidation state of lanthanides. We say lanthanides. Right. So and a stable oxidation state we can write because this is the right answer. So C is the right answer for this question, because reduction potential is more. Now question number 8 from this question, which among the following pairs of vitamins is stored in our body related to for a longer duration? Thiamine and vitamin A, ascorbic acid and vitamin D. So thiamine and ascorbic acid, vitamin A and D. So if you want to know this answer for this question, and we must know two types of vitamins. One is water soluble and other one is fat soluble. So vitamins are classified into two types. Vitamins are classified into two types: water soluble and fat soluble. The water soluble vitamins are B complex vitamins, and fat soluble A, D, E, K. So B complex vitamins, so example thiamine, and vitamin C. So these water soluble vitamins easily can be excreted from our body along with the urine, and A, D, K vitamins. So particularly A and D vitamins are stored in liver. So for long duration. That means if you take vitamin A dose, then it can be stored for almost 6 months. It can be stored in the liver. So then which is the correct option here? D option we can tick. Vitamin A and D is the correct answer for this question. Now question number 9. The ninth question is, which of the following is Lindlar catalyst? So the Lindlar catalyst is partially deactivated, palladized charcoal. So A is correct answer. And cold dilute sulfuric acid, no. And sodium and liquid, this is not right. Means not correct. Zinc chloride and HCl also wrong. And this is the first option is right. Lindlar palladium based uh, catalyst, we say Lindlar catalyst. So we use for the reduction purpose, we use right. So that is 10th question. Now 10th question is given below are two statements, one labeled as assertion, other is labeled as reason. Now H2O, so bond angle in water is 104, so 0.5 degrees. Reason, lone pair repulsion of electrons is higher than the bond pair repulsion. So absolutely right. So in the light of the above statement, choose the correct answer from the options given below. A is false, but R is true, so wrong. Both A and R means assertion, reason are true. Reason is the correct explanation. Okay, right. So it seems to be B. And so now eliminate C, and B is correct option, because if you look at this water molecule, so shape is angular, because there are two lone pair of electrons are present, and the bond angle is 104 degrees, 104.5 degrees, we say 104 degrees 5 seconds. Okay. Now here, as per the Vesper theory, lone pair repulsion is repulsion is greater than lone pair repulsion is greater than bond pair. So lone pair repulsion, because of this repulsion between lone pair bond pair and lone pair versus bond pair, means lone pair repulsion is greater than lone pair versus bond pair. So next this one and last this one. So then bond angle 104 degrees 5 seconds is right. So then option 10th option is both correct explanations. Bond angle is adjusted to 104 degrees. In chromatography technique, the purification of compounds independent of physical state of the pure compound, not on the solubility, so not on this length, not on the mobility, so only A option is the correct one. The type of pollution that gets increased during the daytime and in the presence of O3, so the type of pollution that gets increased during the daytime in the presence of O3, acid rain, oxidizing smoke, reducing smoke, global warming. So generally ozone undergoes in the presence of sunlight, it decomposes to O2 plus nascent oxygen, and this nascent oxygen causes oxidation of pollutants. Then we can write oxidizing smoke we can write. So this is B option is right. The B option is, so we can go for that B option, which is correct option, we can say. And now question, you can look at this 13th question is given here. 13th question is aniline is given. So aniline is given here. So aniline is given subjected to azodite test, and aniline is converted to means NaNO2 plus HCl. So NaNO2 plus HCl is the reagent at 5 degrees Celsius temperature. It can changes into HNO2 plus NaCl. The HNO2 react with this amine means aniline and produces the compound is what we call this compound diazonium chloride. Diazonium chloride is produced N2 plus Cl minus is produced diazonium chloride formation we say. And so when this compound is treated means A reagent, we can get alcohol. So since diazonium chloride is unstable at the room temperature, so upon heating this in the presence of water H2O, subject to hydrolysis followed by this heating, and we can get so phenol. We can get the phenol compound. That means the reagent is the water upon heating, and so we can go diazonium chloride option is IA. So C option is right. So for this question, C option. Now 14th question match the following. So hypophosphorus acid. Now here is given match the following list name of the oxo acid. Oxidation state is given. First of all, we should know the formula for this question. Hypophosphorus acid is H3PO2, and in this, so structure if you write two hydrogen bonds directly with the phosphorus, one OH bond, other double. So now in this, the phosphorus with hydrogen negative character, and so with the +3 and -2. So the oxidation state will be of this phosphorus will be +1 in this. And if you go, because here is with oxygen +3 and with hydrogen -2, so difference is +2 +1, you will get orthophosphoric acid. Orthophosphoric acid is H3PO4, and in this phosphorus will make OH bond. Hydrogen is not connected directly, so this is the structure. So one is phosphorus with the double bond, and only single bond here is OH. So three OH bonds connected to phosphorus. So one oxygen double bond with the phosphorus. So here is now +5 oxidation state. Phosphorus oxidation state is +5 here. Phosphorus will have +5 character, no negative character in this. And orthophosphoric, hypophosphoric acid. Hypophosphoric acid is, so hypophosphoric acid H4P2O4. In this, two phosphorus between that OH, and here is OH, here is OH. So in this +4 character of this +4 oxidation state of the phosphorus, right? Because between here is elemental form, 0 oxidation state here, 0 oxidation state, and rest will be the +4 oxidation state. We can say average oxidation state is a +4. We can write. Orthophosphorus will be H3PO3 here. So in this, the phosphorus oxidation state is phosphorus will make, so one hydrogen, OH, and O. So here is +3 oxidation state here, +3. Now first one +1 we got, and +4 here is a +4 we got, and here is +5 we got here, and here is so +3 we got here, +3. Now oxidation states, so we got here is +1, +4, +5, +3. Now so we'll Hypophosphorus acid is how much? +1. +1 is fifth. Orthophosphoric acid is +5, 1, fifth 1, fifth 1. Hypophosphoric acid is +4, 2, okay. And orthophosphorus acid is +3. +3. So D option is correct. D option is correct. Now the question number 15. Question number 15. So question number 15. Now the question number 15, here we can see which of the following reaction does not involve Hofmann-Mains bromide degradation. So Hofmann bromide degradation, look at this. Generally Hofmann bromide degradation, condition for this is that CH3CO NH2, that means amide functional group. Amide functional functional group will undergo Hofmann bromide reaction in the presence of Br2 NaOH free agent. So and produces 1 degree amine, 1 degree amine, we say 1 degree amine. For example, in this case A, so CONH2 group is there in the presence of bromine and NaOH. So 1 degree, this is 1 degree amine. This is right, it will undergo. And the second case here is so COCH3, this is COCH3, so ketone functional group is there. Treated with this, then this is not what we say, this is Br2 NaOH followed by hydrolysis. This is iodoform reaction. Iodoform reaction. Okay, by iodoform reaction, this bond is broken here. Then we can get the compound is, what compound we can get? CH2 CO O Na we can get, plus CHI3 we get, followed by ammonia. So ammonia salt we get. Upon heating, we can get the compound is CH2 CO NH2 we get. So upon heating this compound, we can get this compound. But here third reagent is given for us lithium aluminum hydride is given. So followed by water. So lithium aluminum hydride, so will give it is a reducing agent. Then we can get the compound is CH2 CH here reduction. Here we can reduce CH2, right? So and we can get so here is since we are using lithium aluminum hydride, so we cannot get the 1 degree amine here. So because hydrolysis also there, carboxylic acid we can get. NH2 is removed by this, so carboxylic alcohol functional group we can get here because of this water. So that means here is 1 degree amine is not possible in this case. So then this is B option is wrong here. And see here option is you can compare here. So 2 carbons are there, and here is the carbon number is see. And one more important thing we have to remember, in Hofmann bromide reaction there is a decreasing of number of carbon atoms, number of carbon atom is taking place. But here carbon atom is not changed here. So, and B option is does not involve Hoffman bromide degradation. And whereas C, you can see NH3. So this CH3 is removed by NH2, CONH2, we can get HCl aega, HCl we can get. So, and followed by Hoffman bromide reaction. This is right. And followed by hydrolysis. So then CONH2 we can get. So then followed by Hoffman bromide reaction, 1 degree amine. So this is right. So D is right, C is right, but B doesn't. So follow this Hoffman bromide reaction. Now let us move to 16th question. The 16th question is statements. Two statements are given here. One is calcium chloride, so hexahydrated. Magnesium chloride, octahydrated, undergo dehydration and heating. So both dehydration. And beryllium oxide is amphoteric. Various oxides of the oxides of other elements in the same group acidic. So that means here we have to observe calcium chloride. So how much H2O? 6 H2O. So this undergoes hydration and loses water molecule. Calcium chloride plus water molecules we can remove dehydration. But magnesium chloride 8H2O upon heating, so it loses some water molecules but not all, and it can form saturated liquid it can produce. That means so 100% water molecule cannot be removed, it becomes into liquid. So dehydration is not possible. Complete dehydration is not possible. Complete dehydration is not possible in this case. Complete dehydration is not possible in this case. And BO is amphoteric, right? Absolutely right. Amphoteric so the same group oxides like MgO and calcium oxide are basic, not acidic. Basic. So with this you can guess which is the, so both statements are wrong, and the statement both statements 1 and 2 are false. False. Now 17th question is group 15th element metal and forms hydride, the strongest reducing power among the 15th hydrides. So, and arsenic, stibium, phosphorus is a non-metal, and he told metal here. So metal means stibium is a metalloid, arsenic is a metalloid, and bismuth is metallic property. Bismuth is right answer. A is the right answer in this case. The process that involves the removal of sulfur from the ores is roasting. Roasting means the process removal of sulfur from this is, so roasting process we can tell. 19th question. The 19th question here, the given below are two statements. Hydrogen peroxide can act as a statement 1. Hydrogen peroxide can act as a both oxidizing and reducing agent in basic medium. In the hydrogen economy, the energy is transmitted in the form of dihydrogen. So both statements are true. Hydrogen H2O2 oxidizing and reducing agent in so basic medium. H2O2 can act as a both oxidizing and reducing agent in basic medium. In the hydrogen economy, so the hydrogen is transmitted in the form of dihydrogen. In the light of above statements, so choose the correct option from the given below. So both statements so are false. So, okay, eliminate this one. Statements 1 is false, and but statement 2 is true. Both statements 1 and 2 are true. Statement So here is C is a correct option. We can go. The functions of antihistamines are antacid, anti-allergic. Okay, so these are the answers for this question paper, part A. Part A. So next we'll discuss part B, section B we'll discuss.